Hey everyone, this is Aili Bhattacharya and welcome back to the channel. So, you have learned about averages, right? The mean, the median. They tell us where the center of our data is. But what if I told you that just knowing the center can be, well, a bit misleading? Imagine two pizza shops. Let me get a pen. Alright, let's take a different color with a light version. Yes, zooming it in. So, imagine two pizza shops. Okay, they both have the exact same average delivery time of 30 minutes. But are they the same? Absolutely not. One is always between 28 to 32 minutes, which is super consistent. The other is all over the place, sometimes 15 minutes, sometimes 45 minutes. That difference, my friends, is what we call dispersion. And today, we are diving deep into it. Stick around because things are about to get spread out. All right, let's kick things off with the big idea. The why. Why do we need dispersion? An average is like knowing the center of a city on a map. But dispersion tells you if the city is compact and walkable or if it is sprawling for miles and miles. It tells us about the variability, the spread, the consistency of our data. We break down the measures of dispersion into two main families, okay? First is absolute. All right, absolute measures. These are the raw numbers. Okay, raw numbers. They tell us the dispersion in the original units of the data. Think of it as saying the data is spread out by 5 centimeters. All right. Next comes the relative measures. These are ratios or percentages. Ratios or percentages. All right. They are unitless, which makes them perfect for comparing the spread of different data sets. Like asking, is the height of plants more variable than their weight? Like that. Got it? Absolute for the raw facts, relative for the comparisons. Now let's meet the absolute measure starting with the simplest one, the range. The range is the simplest measure. It's just the difference between the superstar and the underdog in your dataset. Super easy to calculate. As you can see, this is the formula. Advantages. First, it gives you the maximum possible difference between any two observations. Actually, this is the second. First is it is easy to calculate. Third is it is super useful in statistical control, statistical quality control, SQC, for making control charts. Okay, disadvantages, and here's where it gets interesting. First, it's a drama queen. It only cares about the extreme values and completely ignores everyone in the middle. If you have one weird, out of nowhere value, the range blows up and gives a misleading picture. Next, it doesn't tell you anything about the shape of the data. And third, you can't even calculate it if your frequency distribution has open ended classes, like age 65 and above, like that. So the range is like getting the gossip from only two people in a huge party. You get some info, but you're missing the whole story, right? Now, coming to the next one, the compromiser, mean deviation. To fix the problem of ignoring the middle values, we have the mean deviation. It's the average of the absolute deviations of all observations from a central value, like the mean or median. What is the formula for it? The formula is this: mean deviation about A is 1 by n summation I running from 1 to n bars modulo from xi minus a and then again a bar. This is the absolute deviation. Okay, this part. So the vertical lines here, this one, mean we take the absolute value. We ignore negative signs. We just care about the distance, not the direction. Now coming to the advantages. Hooray! It's based on all observations, right? Finally, everyone gets a say. And disadvantages, but here's the catch. Ignoring the signs by taking the absolute value makes it mathematically clunky. It's not very friendly for advanced algebraic treatments. It's like trying to do complex surgery with a butter knife. Now, coming to the next part, the middle manager, quartile deviation, also known as the semi interquartile range. This one is super cool because it focuses only on the middle 50% of your data. It's the average of the distance between the 75th percentile, Q3, and the 25th percentile, Q1. Think of it as ignoring the top 25% of overachievers and the bottom 25% of, well, the ones still figuring things out? Yes, it just manages the solid, reliable middle class of your data. What is the formula for it? Let me write it clearly again. Quartile deviation is equal to Q3 minus Q1 divided by 2. This is the formula. So, now coming to the advantages. Yes, here. Pros. It's not affected by extreme values or outliers. Since we chop off the ends, those crazy values don't influence it. This is its biggest strength. And next is because of this, it can be calculated even for frequency distributions with open end classes. So if your data has some wild, unpredictable values, quartile deviation is your go to stable friend. Now, coming here, we have one disadvantage too actually. Let me write it here only. Just a minute. Disadvantage. It leaves out 50% of the observations and does not depend on the magnitude of all observations, right? Because the first 25%, you see, the first 25%, here you see this, focuses on middle 50% of the data. The first 25%, the last 25% is not looked at. So, what do we write? Leaves out 50% of the observations and does not depend on the magnitude of all observations, as we have seen. Now, coming to the next part, the gold standard, variance and standard deviation. And now, like the superstar, the one you'll see everywhere, variance and its sidekick, standard deviation, we'll study that. This is sigma, standard deviation, okay? So, variance is the arithmetic mean of the squares of the deviations from the mean. Whoa, that's a mouthful. Let's break it down. We take each data point, subtract the mean to find its deviation, square the deviation. This gets rid of the negative signs, right? But in a more algebraic way that just then ignoring them. Yes. And then average all those squares. But the variance is in squared units. What does squared centimeters even mean? To get back to original units, we take the square root, and that gives the standard deviation. This is the measure we actually use and interpret. So, what is the formula for variance? Variance for x, which is sigma square, is written as 1 by n summation 1 I running from 1 to n xi minus x bar square. Okay, this is the formula. And for standard deviation, this is the formula. Sigma is root over variance. Okay, now coming to the advantages of standard deviation, the VIP treatment. First, rigidly defined and based on all observations. It's precise and uses all the data. Okay, first. Second, it's least affected by sampling fluctuations. This is a superpower. If you take multiple samples from the same population, the standard deviation will jump around much less than the range or other measures. It's stable, reliable estimate, right? Number three, it works with advanced math. Like, how do I say it? amenable to algebraic treatment. Unlike mean deviation, you can do complex math with it. For example, if you know the mean, SD, and the size of two groups, you can calculate the standard deviation from the calculate standard deviation for the combined group. You can do that with the other measures we have discussed, right? See, you can combine the groups. For the limitation, just like other absolute measures, you can't use it to directly compare the dispersion of data sets that are in different units. You can't compare centimeters with kilograms. For that, you would use a relative measure like the coefficient of variation, which we'll cover in the next video. And yes, here you can see the quick comparison. I will upload the notes so you can study from there. So that's a wrap up for part 1. We have covered the A to Z of dispersion from the simple range to the powerful standard deviation. Now, I have a question for you. Which measure do you think is the most underrated, the simple range or the stable quartile deviation? Let me know in the comments. Next time, we will dive into the properties of standard deviation and those all important relative measures. So, if you found this helpful, smash that like button, subscribe to the channel, and hit the notification bell so you don't miss part 2. Thanks for watching, and remember, understanding the spread is just as important as finding the center. So, stay curious. Bye. This is the full notes.